breaking news, and this is huge. Google just made a leap in quantum computing that will advance the timeline several years. Quantum is probably less than 3 years away now, which means artificial intelligence is going to explode even faster than the crazy pace it's on.
You're absolutely right to connect those two things. Google's new Willow chip is a major development, and it has a lot of people talking about the future of AI.
Okay, so for those of us who haven't been glued to quantum news, what makes Willow such a big deal?
It all comes down to what quantum computers can do that even the most powerful supercomputers can't. Instead of bits, which are either a 0 or a 1, quantum computers use qubits. These qubits can be in multiple states at the same time. Think of it like a coin spinning in the air. It's both heads and tails simultaneously until it lands. That lets them crunch numbers in ways that are mind-bogglingly fast.
So if qubits can be in multiple states, that means more processing power, right? But how much more powerful are we talking? Give us a sense of scale.
Imagine a task that would take longer than the entire universe has existed. That's the kind of difference Willow is making. It can solve problems in minutes that would take classical computers septillions of years.
So it's not just a little bit faster, it's like entering a whole new dimension of speed. I remember reading that one of the big challenges with quantum computing has been something called error correction. What's that all about, and how has Google apparently cracked the code?
You're right, error correction has been a major hurdle. Qubits are incredibly sensitive. Even tiny changes in temperature or stray electromagnetic radiation can disrupt them. It's kind of like trying to have a phone conversation where there's so much static you can barely hear the person on the other end.
And that static, those disruptions introduce errors,
Right.
making the results unreliable.
Exactly. For decades, scientists have been trying to find ways to clear up the static and make those calculations more stable. Google's breakthrough with Willow is that they've achieved a new level of error correction, a problem that researchers have been wrestling with for 30 years.
Okay, so less static, more clarity. This error correction thing is what makes Willow such a game changer. Why is that such a big deal?
It's a big deal because it opens the door to building even larger and more powerful quantum computers. The more stable the qubits, the more you can pack together and the more complex problems you can tackle. While Willow is still mainly experimental, it's giving us a glimpse of what's possible.
So Willow's proving that the quantum future is closer than we thought.
Yeah.
But hold on. We need to address the elephant in the room, AI. You mentioned it earlier, and I know it's something our listener wants to dive into. Will quantum computing supercharge AI?
Absolutely. And that has the potential to be both incredibly beneficial and something we need to be very thoughtful about.
Okay, now I'm even more intrigued. Break it down for us. How do quantum computing and AI intersect?
Think of it this way. AI, especially machine learning, is like a hungry learner. It thrives on data. The more data you can feed it, the faster and better it learns. Now imagine giving that learner access to a quantum computer that can analyze massive data sets at speeds unimaginable for regular computers. AI algorithms could become exponentially more powerful and sophisticated.
So we could see AI solving incredibly complex problems like developing new life-saving drugs or modeling climate change to find solutions.
Exactly. The potential is there for incredible advancements in medicine. Climate science materials design practically every field you can think of. But as with any powerful tool, there are potential downsides.
Okay, I'm hearing the excitement, but also a note of caution. What are some of the things we need to be thinking about as this technology evolves?
One of the biggest challenges is ensuring responsible development. As AI becomes more powerful, we need to make sure it's used for good and not for harm. That means building in safeguards, thinking through ethical considerations, and having open discussions about the potential impact on society.
So Willow isn't just a cool new piece of tech. It's a sign that we're entering a new era, and we need to be prepared for both the opportunities and the challenges that come with it. But before we get too carried away with those big picture questions, let's zoom back in on Willow. It's not just about raw power, is it? What are some of the specific ways Google sees this technology being applied?
You're right, Willow is more than just a benchmark crushing machine. Google has highlighted a few key areas where they see quantum computing making a real difference in the near future, and one of the most promising is medicine.
Okay, tell me more. I'm always up for hearing about how tech can improve healthcare.
Imagine being able to design drugs with much greater precision, targeting specific diseases at the molecular level, or developing personalized therapies based on an individual's unique genetic makeup. These are the kinds of breakthroughs that quantum computing could enable.
Wow, that would be revolutionary. What else is on the horizon?
Another area where quantum computing is showing huge promise is in battery technology. Quantum simulations could help us design batteries that are far more efficient and longer lasting, which would have huge implications for everything from electric vehicles to renewable energy storage.
Longer-lasting phone batteries. I'm already sold. But seriously, the potential applications seem endless. It's almost like we're limited only by our imagination at this point.
That's a good way to put it. We've got this incredibly powerful new tool, and we're still figuring out all the amazing things we can build with it.
It's mind-blowing to think about the possibilities, but it's also a little daunting. Are we even ready for this?
That's the million-dollar question, isn't it? But here's the thing. It's not just Google in this race. Countries like India are investing heavily in quantum computing research and development. They're even working on their own quantum computer.
Wait, really? India's in the quantum game too. This is bigger than I realized.
Yeah.
It's a global race.
It absolutely is. And that's why it's so important to have these conversations about responsible development and global collaboration. The decisions we make now will shape the future of this technology and its impact on society.
So we've got Google pushing boundaries with Willow, and now you're telling me India's in the race too.
Mm-hmm.
What's their approach? Are they doing things differently?
What's fascinating is that India's approach is multi-pronged. They're investing in research and development like everyone else, but they're also really focused on building a skilled workforce. They've launched initiatives to train a whole new generation of quantum scientists and engineers because they recognize that talent is key to success in this field.
So they're playing the long game, investing in education and infrastructure to build a sustainable quantum ecosystem. That's smart. What about their quantum computer? What can you tell us about that?
Their flagship project is being spearheaded by the Tata Institute of Fundamental Research, and they're aiming to have a 24-qubit system up and running in the next 3 years. Their ultimate goal is to build a 100-qubit system within 5 years. To put that in perspective, each additional qubit exponentially increases the computer's processing power.
Wow, those are ambitious targets. It sounds like they're not messing around. But here's a question that's been bugging me. Why are so many countries pouring so much money and effort into quantum computing? What's the ultimate payoff?
That's the billion-dollar question, literally. The potential applications are so vast and transformative that it's hard to overstate their significance. Imagine a world where we can develop new materials with unprecedented properties leading to breakthroughs in everything from energy to transportation. Or a world where we can simulate complex biological processes leading to cures for diseases that are currently incurable. These are just a few examples.
It's like we're talking about science fiction becoming reality. But here's the thing. With all this talk about the future, I'm curious about how quantum computing is being used right now. Is it all just theoretical at this point, or are there any practical applications already in play?
That's a great question, and it's important to understand that we're still in the early stages of quantum computing. It's a bit like the Wild West out there, with lots of experimentation and exploration going on. But there are a few areas where we're starting to see some real-world applications emerge.
Okay, give us the scoop. Where is quantum computing already making a difference?
One area is cryptography. Quantum computers have the potential to break the encryption algorithms that we currently rely on to secure our online communications and financial transactions. This has sparked a race to develop new quantum-resistant encryption methods.
So it's like a cybersecurity arms race with quantum computers as the new weapon. That sounds intense.
It is, and it's not just about protecting our data. Quantum computing is also being used to improve optimization processes in various industries. For example, companies are using quantum algorithms to optimize logistics and supply chain management, leading to cost savings and increased efficiency.
Wow, it's amazing to see how this technology is already having a tangible impact, even in its early stages. But let's be real. Most of us aren't cryptography experts or logistics managers. What does this all mean for the average person? How will quantum computing affect our daily lives in the years to come?
That's where it gets really interesting. If we zoom out to the big picture, quantum computing has the potential to revolutionize so many aspects of our lives. Think about personalized medicine tailored to your individual genetic makeup. Imagine ultra-fast drug discovery leading to cures for diseases that currently plague us. Or consider the development of new materials that could lead to more efficient solar panels, lighter and stronger airplanes, or even self-healing electronics.
All right, we're back. And I have to say, this deep dive has really opened my eyes to the world of quantum computing. We've covered so much ground, from Google's Willow chip to India's quantum ambitions, and even the potential risks and challenges we need to be thinking about. What's been the most surprising thing for you?
For me, it's how quantum computing is already making a difference in the world. We tend to think of it as this futuristic technology, but it's already impacting fields like cryptography and optimization. It's a reminder that this isn't just science fiction, it's happening now.
That's a great point. It's easy to get caught up in the what-ifs and overlook the real progress that's being made. But let's shift gears and think about our listener for a moment. What are some key takeaways you'd want them to walk away with? What should they be pondering as they process all of this information?
First and foremost, I'd say pay attention to the pace of change. Quantum computing is evolving rapidly, and it's going to have a profound impact on our lives, even if we don't fully understand the technical details.
Right, it's like a tidal wave is coming, and we need to be ready for it.
Exactly. And that brings me to my second takeaway. Don't just sit on the sidelines. Engage in these conversations about the potential impact of quantum computing. Talk to your friends, your family, your colleagues. Read articles, listen to podcasts, and educate yourself about what's at stake.
It's like we all need to become quantum literate citizens.
Right, absolutely. The more we understand about this technology, the better equipped we'll be to shape its development and ensure it's used for good.
This has been an incredibly thought-provoking deep dive. It feels like we've barely scratched the surface of what quantum computing is capable of. But what do you say is the biggest question we should all be asking ourselves as we move into this new quantum era?
For me, it all boils down to this. What kind of future do we want to build with this technology? Do we want a future where quantum computing benefits all of humanity or just a select few? A future where it's used to solve our most pressing problems or exacerbate existing inequalities?
Wow, those are some big questions.
They are, but they're questions we need to be asking ourselves now. The decisions we make today will shape the quantum future for generations to come.
That's a powerful thought to end on. Thanks for joining us on this journey into the world of quantum computing. It's clear that this is a topic that's going to continue to evolve, and we'll be here to keep you informed every step of the way. Be sure to subscribe for the latest breaking news and deep dives. Until next time, stay curious.